All right, continuing the integration by parts. Problem six is quite complicated, and I'll run through it. You'll see the issue we're going to have. So I have to make a choice for u. So I use my late. There's no logarithm there, boo, but there is an algebraic thing that is the 6x squared, including the 6. And again, you never, ever pick e as your u. That will never happen. So you have 6x squared is going to be my u. My dv is going to be everything left over, which is ex dx, right? This is the derivative, so he gets the dx. So you're going to take the derivative of u, which is 12x, right? Multiplied by the power, subtract 1, easy peasy. Remember, put a dx there because it's a derivative. Now, you have to integrate. Ugh, doesn't get any easier than that. The antiderivative of e to the x is e to the x. Yay. Check it. Derivative of e to the x is e to the x. Yay, it worked. So I have to do uv minus the integral of v du. So I'm going to do uv, which is 6x squared times e to the x, right? Go across this way. And then v du minus the integral of v du. So that gives me 12x e to the x dx. Now, you run into a problem. That's just like a problem that I worked with. It's very similar to problem 3. That's on the sheet that I worked in the previous one. This is parts again. If it was just this, I would be good to go, but I'm not. But notice, I started off with an x squared and an e to the x, and now I'm down to an x to the first e to the x. So what I have to do, unfortunately for me, is I have to integrate by parts a second time. So there's no way around this. This is not going anywhere. That's there forever. My e to the u is set, but I have to do u and dv again. So I'm going to switch colors this time to make it a little more obvious. My u again is going to be the algebraic thing. My dv is what's left over. This is why I was very nice to you and didn't put like e2x there. It's hard enough having to do this twice. The derivative of u is 12. Yay, right? Derivative of 12x is 12. The x goes away. Times dx. And once again, when you integrate e to the x, you get e to the x. So this is why it's pretty nice. So now again, I have to do uv. Now you're going to be really careful. Watch how I'm going to write this. I'm going to be super careful and it's going to be very long. So I have my original uv right there. It stays there. Minus, now I'm going to put big ass parentheses. Now I have to do uv again. uv right there, 12x e to the x. Okay? And so it's uv minus integral v du. Let's keep track. Minus integral v du this way. Now I'm good because look, I have 12 e to the x dx there. So you end up integrating by parts 2 times. This is craziness. So what I like to do is I like to switch the signs here. So I can drop my parentheses, right? This negative is going to hit there. This negative is going to hit there and switch that to a plus. So let's do that. Let's drop the parentheses. Whoops, not the integral symbol. Jesus. Put the plus there. Put the minus there, right? So the negative one here and here. So now all I have to do is integrate that. So I have my 6x squared e to the x, which was my original uv. Then I had another uv and another v du. That's the second time. So you have the 12x e to the x. And then this is the easy, it doesn't get easy in that. Constant goes along for the ride. Integral of e to the x is e to the x. And then plus c. And you're like, that's not so bad, but it is. It's horrible. You got to do integration by parts twice. And look at this. Look at that antiderivative. It's crazy. So integration by parts 2 times. You go through it once and you get to your integral, right? The whole point of integration by parts is to get to this step and have something that you can integrate easily. Didn't happen. I got something that I had to use parts on again. So I did. I used it again. But I have to be very careful with the signs. It's really easy to screw that part up. So I hope I made it clear. Now, as reluctant as I am, 7. 7's worse. 7 gives you, you're going to see, it gives you an infinite loop that you cannot escape from unless you're very clever. All right, so this is going to be the last one, and you're going to see how god-awful it is. If you don't have any L and an A, right? You don't have a log, you don't have algebra. These are always really nasty. If you're down to T and E, you pray. Because it's not going to be nice. So, but given the choice between a trig dude and an E dude, the trig dude wins the battle. So you have to pick that as the U. and the dv has to be everything that's left over. Now you're going to see what's going to happen. This is going to be pretty ridiculous. And I'm going to write this a little differently than I did the other ones, and you'll see why. So you're going to do the derivative of sine, which is cosine. You're going to do the integral, right? You're going to find the antiderivative of e to the x, but that's just e to the x. So now I'm going to play my game. I'm going to do my uv, which is exactly what I started with. So it's sine x times e to the x. You can put that in the front, but I'm going to leave it the way it is. Minus, right? It's uv. Should write that down. I told you to write it down. So it's uv minus the integral of v to u. So it's going to be cosine minus the integral, cosine x. Help if I write it correctly, cosine x, e to the x. I've done so many of these, my brain is starting to get fried. This happens. So uv minus the integral of v to u. There you go. You see, I forgot my dx. I put it there. Hey, listen, I got to be precise. So now, look at this. It's like, it's almost the same thing you started with. It's like, oh, brother. So you have to do parts again. So once again, given a choice between the trig dude and the e dude, you got to pick the trig dude. So now the derivative of cosine is negative sine. And then everything left over was the dv. So when you integrate that, you just get e to the x. So now you're going to play the game again. You're going to do uv minus integral v to u. Right? This is the game. You go across diagonally, and then you go straight across. That's there forever. It's not going away. So you get sine x e to the x minus, now put big parentheses. I got to do my uv again. This time uv is cosine x e to the x times minus integral. Now go this way, right? It's v du. So it's negative sine x e to the x dx. And yes, I forgot my dx here. At least I put it there. So all I can say at this point is whatever. So now, like I told you before, this is really vicious with the signs. I have this negative, and I have this negative. I'm going to create a positive from them, right? I'm going to take that negative out into the front and make it a plus. Now, I'm going to do one more thing, because I still have this negative that's going to distribute to here and to here. That's why I took this negative and I made them a plus. So this negative is going to go here. It's going to be really hard for me to write this. So it's going to be, you know what, I need the space, so I have to do it this way. I'm going to distribute the minus here and here. So let's make sure I don't erase my integral symbol this time. So that's going to be a minus, and then this switches back to a minus, right? So there we go. Now, unfortunately for you, you're back to where you started. This is important to notice, because if you don't notice this, you'll be like an idiot. You're going to see kids doing it again and again and again. Integrating by parts again is going to just take me right back to here. You're trapped in a loop that is infinite and not going to end. You're stuck there. You're going to always get back here, which is where you began. And it's a big problem. You have to, so it's very clever to get out of it, because integrating by parts anymore just leads you right back to the same loop again and again and again, and it's not going to go anywhere. What you have to do is realize that what is all this equal to? All this crap that you wrote is what the original integral was. So you're going to write the original integral down. Right? This was where I started. I started doing integration by parts. I got this. I had to do it again. I got this and this by doing it a second time. So I got this whole big long nest there. But it's important to notice. Look. Boom. 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 I have, it's like, you know, I had a y equals, I don't know, 3x minus radical 16, I don't know, q minus y. And the thing is to solve for y. So you would take the y and add it to both sides. Choop, choop. And then on that side, you'd have 2y. Hoping none of my calc students again think that y plus y is y squared. You could go away if you think that. Stop watching my videos and just drop out of math forever. All right? Y and y make 2y. So that's the situation I have here. I have this weird equation. Remember, it's still an equation, right? It's still an equation. It's this equal to that. So I'm going to add this dude. You're like, you can't do that. It's an integral. It's still it's still a mathematical expression, right? It's still an object that you can move and manipulate. So I'm going to add it from that side to this side. And you think, how the hell are you doing this? You can't just add this over the integrals. But look, if you have this integral and you add the same integral to it, you get 2. So these cross out and you get 2 of that integral. You double the original integral because look, it's there again. It's there again in the loop, so you have to get rid of it. So I added it over, so now it's gone. Right? I added it to the other side, it's gone. So now what's left over there is this crap. I have sine x e to the x, and then I have cos x e to the x. And this is what I'm solving for, but I have it times 2. And you know the opposite of timesing by 2 is to divide by 2. So I'm going to divide this 2 away, which is going to give me the original integral I started with, and just put 2's underneath these. And don't forget your plus c. Like, what? It's over. This is the way that you escape from the loop. As soon as you get back the integral that you started with, you have to do that weird ass thing that I just did. If you have it on both sides, there was another one right here. So what I did is I added it over to, and it was minus. I added it over to this side to make 2 of them, and then I divide that 2 over. So believe it or not, this is the answer to number 7. It wasn't enough to do integration by parts twice. I'm trapped in a loop. It's not going to end. I could just sit there and keep doing integration by parts again and again and again and again. It's not going to stop. It's going to keep looping back to where I began. So that's why the only way to escape the loop is to just make this weird algebraic manipulation. But that's why I'm showing it to you, because I don't expect you to come up with that crap on your own. This is why I did it. And just hope, beyond hope, that I don't ask you something like this, because this is very nasty. But this is how you would do it when you get, and this will always happen with a trig dude and an e dude. You get stuck in these very nasty loops that there's no escape from. You can integrate by parts again and again and again, and it goes nowhere. So the only way to get out is to do what I did. All right, so this is what it is, and you're more than welcome to take that derivative and see that it matches there. I ain't doing it. All right, so again, hopefully that helps you. Now I was gonna do one more. I did want to do this one. I will give you the hint though. Remember, your u is always going to be natural log. What's left over is that there's a 1 dx. I don't want to finish it because I have it in the homework, and I want to make sure that everyone in the class can do it. But that's the hint to begin it, right? The u, if you see ln, that's the u. And you're like, but there's nothing left over. There is. There's a 1, and there's a dx left over. So should know how to integrate that by now. All right, so that was 6 and 7, and I'm not doing it anymore.